So the second speaker is by Tristan Braud, who is assistant professor at Hong Kong University of Science and Technology in the Division of Integrative Systems and Design. His research focuses on augmented and virtual reality with a specific interest in human-centered design. With his research, Dr. Braud aims at bridging the gap between designing novel systems and human factor inherent to new technology. So today's topic by Tristan is augmented reality for arts, limitations, challenges, and perspectives. Tristan, all yours.
Thank you. So good afternoon, everyone. So as Professor Zhang said, I'm going to talk about augmented reality for the arts under a few different perspectives. So first of all, a little bit about myself. So I am, as was introduced, assistant professor at the Division of Integrative Systems and Design at HKUST, where I also lead the XRIM lab for extended reality and interactive media. So what we focus on is augmented reality, virtual reality, empathic computing, and gaming. And we have two approaches actually to this. We really try to bridge technical expertise with human factors. So originally, I am not an artist. I am actually not even really into human factors by training. I did a master's in telecommunication, to which I moved on to a PhD in computer networks. And then I started working more on augmented reality, which is a discipline which is very highly dependent on what the user sees and what the user experiences. So in my lab, we worked on many different projects that go from very, very technical projects, such as cloud gaming architectures, to AR frameworks and applications, interaction methods in extended reality in general, some privacy aspects as well, because in augmented reality, of course, you are very rapidly hitting issues with privacy. And more recently, something more related to large to very large scale extended reality systems and the metaverse. And this is what the second part of my talk will focus on. But first of all, I want to give a little bit of background about how is augmented reality used in arts. So augmented reality, let's agree together on the definition that I will use in the rest of this presentation. So augmented reality is about overlaying digital content on top of the user's view of the physical world. So there are several implications about that. The first one that I would like to insist on is that it should be most of the time real time. Because I have seen a lot of works that talk about augmented reality which is more of digital content overlaid on a video, which to me doesn't really matches as augmented reality. It's more like CGI. And the second thing is that it interfaces really digital and physical. So one aspect that is very important for a good augmented reality experience is to actually integrate the digital content within the physical surroundings of the users. So for instance, if you have a wall, don't display content beyond the wall. The limit for displaying the content is on the wall. What is behind the wall should be hidden. If some objects or some people go in front of the digital content, then occlusion should be managed, and so on. So in the next few slides, I will display a few of the different techniques that are well known and that are widely used to do some augmented reality art experience. So the first one is just using images and markers. This is the most basic way we do augmented reality, which is you have a 2D pattern. So that can be an image, that can be a marker, that can be a QR code, that can be a lot of things, as long as it's two-dimensional. And these can be detected very quickly nowadays by our mobile devices. So you use those 2D patterns to anchor digital content around it and track it. So here I gave a few examples of what has been proposed in the arts community for those images and markers. So typically there is Untold Stories, that is an exhibition that happened at the Tate Britain, where they expanded the 2D paintings into 3D small scale experiences, so to add more context and content to the 2D images. In Hong Kong, we also had this Art for Everyone application, which I'm sorry for the terrible screenshot, but it's a bit hard to find good images of that. But the idea with that is that I think it's a dozen of paintings that can be augmented to put them in a different context. So typically here, what they did is quite interesting. They took a very traditional painting, and those traditional paintings were exposed in many different places, and especially the metro stations of Hong Kong. And so when you point at this painting with your phone, the background of the painting changes to be a metro car. And another project that I find quite interesting is the MoMA, which is an unofficial application and actually unauthorized, which took one gallery at the New York Museum of Modern Art and overlaid some different content. So you can consider that a little bit as digital vandalism, where they're technically not doing any material damage, but they propose an application where they take over the content of the gallery. Just to show you a bit what can be done, this is a technical demo that we did for the HKUST Guangzhou campus opening, just by tracking an image. So as you can see, the possibilities are quite deep, where you can have literally giving this impression of portals and displaying content behind the image, and have 3D objects that really pop out of the screen. All right, so the second technique that has been used quite a lot in the world of art and in AR is environment tracking. So what you do for those things is that you detect and track the user's environment. And so the user's position of the device in the space. With that, you can anchor objects in a location that is local to the experience. So here are two examples that have been done to actually mostly to promote platforms that allow you to do that. So you have this one, I'm not sure how to pronounce, that allows you to place those kind of objects anywhere you want, and to transport this AR exhibition with you wherever you want. And the same principle was also done with Jeff Koons, who did some of his famous balloon animals in collaboration with Snapchat. A direct application of this environment tracking that actually a lot of friends I have in the art community have shown interest for is AR Doodle. So that's an application that is proposed by Samsung on their phones, and it's quite interesting because you scan the environment and you can very easily start drawing in augmented reality. So here I'm just drawing hello. This is a video I took quickly this morning, so I'm sorry for the kind of poor quality, but I just want to display how the environment tracking works, because now this is anchored in our space and you can move around the drawing and eventually even do 3D drawing if you want to. So another way to push it a bit further, because so far we've seen two techniques. The first one that is more on very local experience that is attached to a 2D marker, or a very global experience that can be done everywhere. And in between, one thing that has been offered is also using the GPS and the magnetometer of the smartphone to have an approximate ID of the location and the pose of the user. And you can do that to geolocalize AR art installations. So typically, this is what the fourth wall coordinates platform allows to do. And also, there was this AR exhibition that happened in Miami called Augmented, where they displayed at several locations in Miami some AR art. The problem with that technique is that you're very dependent on the accuracy of the GPS, which is at best 5 meters in all weather. And actually, if you live in a place with a lot of skyscrapers, that can go all the way till 20 meters. So it's not really accurate, and it's only on specific use cases that you can actually leverage that. Finally, one last technique is actually detecting certain objects. So most often it is faces and body, because the most popular frameworks to develop AR applications are targeting those things. So typically there is this Central Saint Martin's by Mathilde Rougier that displays some sort of like fashion show in augmented reality, where all the clothes are 100% digital and overlaid on top of the physical models. And you also have Beauty 3000 by Joanna Jaskowska, which is an AR face filter design. I think she's a makeup artist originally, so designed to enhance your face. And also, it can be other objects. So if you go into more technical frameworks, they allow you to scan any objects and to recognize it. A lot of work has been done for car models, because I guess they were the first contractors of this kind of technology. But you can do it with basically any object that has very distinctive features. An example that I found in Hong Kong, and that I have not tried in person, I just found a video of this that seems very similar, is Redefining Reality, also by the Hong Kong Museum of Arts. And they have this sculpture of two arches, physical arches. And those arches, as you can see, are being connected by digital content in augmented reality. So here we have a very good degree of integration between the digital content and the physical 3D objects. So using those techniques, I worked on a few projects with various artists and designers, and I'm going to present you a few of them of what we can do in augmented reality and arts. So the first one is Tiger Hunt, which is a work that is done together with the duo Vara and Mar. And it's a work in progress that aims to anchor digital arts into our physical world. So at the origin, this is a work where some AI-generated tigers were created by Vara and Mar. And we were trying to give them something more physical, some more physicality. So what we did was we placed 9 AI-generated tigers in several locations on the HKUST Clearwater Bay campus, as you can see here. And we used a mix of several technologies actually to try to have a good visual coherence when integrating those tigers. So first, we used the GPS to initially anchor the tigers in the physical environments of the user. But we only anchor it once, because the GPS has very low stability, and we don't want the tiger to move around a lot. So then we use environment tracking to anchor this tiger at one location. So even though the tiger position changes from one run of the experience to the other, across the experience, we keep the tigers in the same position. And also we use light estimation to have the tiger displayed in a way that is somewhat coherent with the lighting. So as you can see here, for instance, this tiger is displayed in the shadows, and so it is not completely lit. Same, we also display shadows that depend on the lighting at the time of taking the picture. So on all of these pictures, actually, if you know a little bit those areas on our HKUST campus, you can see that all three pictures were taken about at the same time, and that the sun is always pointing in the same direction, leading to those shadows. I think the sun was currently at the east, actually, for those pictures. All right, so another project I'm working on right now is accelerating dimensions. So in this one, I'm working with a dance artist, Zilia Zizitan, who wants to propose an experience at the intersection between physical and digital. So what's really interesting here is that augmented reality is only a small portion of the entire experience, because the dancers also leverage motion capture and streaming of this data and projection on several strings, on several screens, sorry, to propose an entire experience at the intersection between physical and digital. And so what we did was we used some markers in the room to be able to locate the content across the room, the digital content. And then we track it across the room. We also do a bit of lighting estimation, and in this case, more importantly, body occlusion, so that the dancers can move around the space and their body will occlude the digital content. So just to show you a few examples, so I'm sorry for the images that are not so great quality. Those are some that I took at the last rehearsal. But here, as you can see, we have our markers in orange that are displayed all around, and we scan them once, and then we only track the performance. And here, as you can see, we're displaying some digital content at each one of the markers. But also, we use those markers to locate content outside of the markers. So for instance, here, you can see this shadow of an avatar that is mixing with the dancer in the center. And so this is what we did. This is by tracking the motion of the device and being able to display content beyond the very strict scope of the markers. Another more academic project, which I've been working on with some of my students, is how to augment exhibitions to bridge the curatorial intent and the audience perception. So the idea is that when you create an exhibition, you display content in a certain order and you group it in different rooms in different ways. For instance, this is one exhibition that relies on the day of the week. This one would be another exhibition that would be more thematic, based on an evolution over time. And so what we try to do on this one is to give an augmented guide to those exhibitions that kind of lead the way between one artwork to the other, and eventually display also more information digitally around the artwork. So for this one, technology speaking, in terms of technology, we leverage much simpler technology. We use the artwork as a marker, and we just track the pose of the user's device between those artworks. And finally, one last project, which is kind of an interdisciplinary project that leverages a lot of different things, is this AR art controller, or the ART controller. This came from a lot of painters came to me to try this tilt brush solution in VR, or this AR doodle solution. And the problem they all experience is that you're trying to draw in mid-air, so you do not have this tactile feedback that you have when you're painting in 2 dimensions on a canvas or drawing on a paper. You cannot experience the grain of the surface. You cannot experience the force feedback from your tool hitting the surface. And so the idea of this project is to devise a controller that would give better painting sensation when drawing in mid-air. So we leverage several techniques like force feedback, vibration, sound, to give more feedback to the artists. So typically we did actually try to analyze paper, what is the surface of a paper like as a microscopic level, to bring back this information under a different type of feedback to the user. We also experienced drawing with a gyroscope so that each motion of the painter actually has a reaction even in 3D. All right, so I showed you a bit what we can do well in augmented reality. And as you can see, that relies on actually fairly basic techniques: image recognition, environment tracking, eventually some GPS, a bit of object scanning. But there's a lot of things we cannot do well that are very constraining actually for artists. The first thing is that one thing we need is an app. Actually, I tried a lot of web AR platforms, and none of them really offers a satisfying experience compared to what you can do with an app. Oftentimes, it's going to be a bit wonky, not very stable, or the tracking is not going to be very performant. Then you have other platforms that offer some sort of AR function, like Instagram or Snapchat, but a lot of it is kind of limited. So for Snapchat, there is a big thing that apparently they have those new spectacles that are only available for artists that have a good portfolio. They need to apply to it, and I don't have a pair of those, so I cannot judge on those ones. But what the Snapchat app allows you to do is quite limited. One thing that we also cannot do well is detecting the absolute location and the pose of the device, especially indoors. So it's impossible to actually anchor a persistent AR experience or a multi-user AR experience with a good accuracy. Occlusion is always an issue as well. And we can do it well only at a few meters. So like typically I gave it the examples of the dance performance, but besides that kind of like limited distance, it gets more difficult. And one thing that I realized when looking for different artworks to present here is that actually attribution is not easy to find. What I mean is that on a lot of cases, I found demonstration by platforms that do not cite the author. On the other hand, sometimes I have artists that present their work, but then it's difficult to know what kind of technology or who did the AR work. And this is something, as we're really at the intersection between technology, very high technology, and arts, that we probably would have to consider at some point how to handle this kind of attribution. So to get back to the second point, I'm talking here about detecting the absolute location and pose of the device. I have a little bit of time, and I want to present one of the projects we're currently working on, more technical area, which is trying to do augmented reality at campus scale. So, as I said before, the main problem with the existing technology is that most applications are single users and non-persistent. There are some frameworks that try to go beyond that, but they're very limited. So like typically Niantic's Light AR works very well at specific locations. And this comes from the fact that they leverage the locations from Pokemon Go to do that. So most points of interest of cities are very well mapped, and you can anchor content there, but you cannot really do that beyond those specific anchors. Then you get Google Geospatial API, which is a very recent thing where they actually use the fact that they have Google Street View, and they can very accurately locate you, but only where Google Street View is deployed. So not really inside. Most of Germany is off limits as well, and so on. And then you get other frameworks like Vuforia, ARKit, or Immersal that works well either at small, like room scale, or they can work well at a bigger scale, but scanning the environment relies on expensive equipment. So what we tried to do in this project is to scale up the technology to large size environments and massively multi-user experience. But it's not easy because many different types of environments present different constraints. I take a campus, you get the main piazza, the atrium, the classrooms that all look the same, the amphitheaters that are quite big actually, and so on. So what we do is we propose a framework that combines local maps built on the device to track the device in the space and global maps that allow to get the absolute pose of the device. And then there is an alignment and registration manager in between that can handle registering the local map onto the global map. So the local map manager is on device, uses the camera images and the sensor data, and it tracks the experience around. Of course, as you move across several rooms, corridors, and buildings in a short amount of time, you need many small local maps. And those local maps will have to be registered onto a global map. So the global map is a map of the entire campus so that all users share the same map and they can have persistent multi-user experience. So this is an example of a scan of the HKUST Clearwater Bay campus. That's 10 million points, I think, from the bus station until the atrium. As you can see, it's massive, 10 million points. And this is because this area is one of the most attractive areas. Of course, we can use 2D and 3D anchor points for less attractive areas. Like, for instance, around canteens, you know that most people will be interested in the canteen, not the corridor that leads to the canteen. So maybe it's not necessary to map the corridor. Also, we want to use crowdsourcing to build and update this map. And then we combine both to provide alignment, camera pose registration, and content display. So I have like just 5 minutes remaining, so I'm going to skip the few remaining slides. And I just want to discuss a bit the applications, because I was talking about an AR campus, and campuses are very specific spaces. First of all, this feature actually a very large diversity of environment, which is a challenge, but also an opportunity, because if you can deploy augmented reality on campuses, you can very easily extend it to urban environments, because you have large-scale indoor environment, large-scale outdoor environment, small-scale indoor environment, corridors, places that all look the same, places that look very different, and so on. So through this project, we hope to not only improve the accuracy of geolocalized experiences outdoors, but also enable shared, persistent, and repeatable AR experience. So I wrote indoor, but technically everywhere, both indoor and outdoor. And to a point where I hope that at some point we could reach the possibility of making augmented reality digital graffiti. And by that, I mean, anybody can pull out their phones anywhere and leave an artwork in this location. And everybody that comes by can see this artwork at the exact same location, wherever it is in the world. All right, so that was it for me. Thank you. And I think we have time for a few questions.
Great. Thank you, Tristan, for your interesting talk. So let's take a couple of questions. I think 3 minutes. We maybe take one question. So let me see. There was a question early on, whether it was for you or for Joe. Yeah, maybe this question is for you. I think the latest question. Let me read it. I think also of the the shock effect comes from, oh, someone actually did it for art. i.e. no real reasons, rather than the science lab context, which always presume research for greater good. Assuming this question is for you, Tristan, would you be able to answer? Oh, no, yeah, Huri said not for you. Maybe let's pose that question later for all the three speakers. Maybe yeah, it's a more generic question. There are some early questions. Maybe we delay until the panel session. Let me see whether anyone specifically for you, Bonnie. Yeah, I think not about AR yet. Okay, there is one question. What's the bottleneck currently for loading digital assets into AR experience?
There are a few bottlenecks. So as I presented, those techniques that I showed in the first place, like images and markers, GPS, scanning, tracking the experience on the environment, and eventually 3D object scanning, those are techniques that are fairly well known and are becoming easier to deploy with little technical knowledge, actually. So the bottleneck in that case will be the artwork themselves. Like that's my problem with working with a lot of like 3D designers, for instance. They often give me models that are several gigabytes wide and that are not only way too big to be run well on a mobile device, but also it's not necessary, because at the end of the day, people will see it through a tiny screen, like 5-6 inches wide. You don't need 4K textures and like very detailed models. So the size of the models is a problem, because of course devices are getting better, resolution is getting better. We're starting to see headsets coming on as well that gives even closer information. But the computing power is not necessarily there to display those big models. And then the other big bottleneck is if you want to go beyond a few meters accuracy in terms of where to position persistent experiences, the bottleneck is completely technical, which is it's actually very difficult to reliably devise techniques that allow you to place content somewhere with a very good accuracy.
Great, thank you. And actually, more questions for you, Tristan. How do you handle occlusion for dynamic objects like human bodies?
On this one, I'm going to be completely honest. I don't do it myself. The framework, there are some very smart people at Apple, especially, that integrated some things in the framework that works very well. But what I would do is that in general, and this is the big problem, the two main techniques to handle occlusion is either extracting depth information out of a single image, which is very difficult, or identifying objects, and from knowing the approximate size of the objects, figuring out where it is. So like, for instance, if I identify a human body, I know it has a very good chance to be between 1.60 meters and 1.80 meters tall. So by finding its size on the camera frame, I can estimate whether it is close, how close or far away it is from the device. And then, of course, you have some devices like the iPad Pro that literally feature a LiDAR that allows you to extract the depth information in real time, because this is literally a depth sensor.
Okay, got it.